Hello everybody and welcome back to Business Statistics. This is the last video for chapter 3, and here we'll talk about bivariate data and we'll talk about characteristics of that data such as sample covariance, sample correlation coefficient, and how to interpret those numbers. So we're going to be using this set of data that represents demand and price on a certain printer. So this would be the demand and X is the price on a printer. And what we're going to do, we're going to compute sample covariance and sample correlation coefficients in two ways. We're going to do it the long way just so you understand how that works, and then I'm going to show you a shortcut. Okay, so that's what we're going to do in this video. All right, so first we're going to talk about how to compute covariance doing the long way. So here's your table. We need to compute the average of the prices, okay, for this particular type of printer, and then the average for the demand. So that is done by typing in the function average and highlighting your cells. Okay, so 85 for the price, 15 for the demand, and now we need to find the difference of each observation and the mean. So we're going to type in equals, highlight the cell, minus 85. Okay, and then you can highlight the cell and just drag it down so you don't have to retype this formula. And these are the differences that we get for price and the average, right? Same thing for Y. The demand, highlight this cell, minus 15. And the differences will be stored here. Okay. Then the next column is the product of the corresponding differences, right? So that would be equal this cell times this. And then we drag it all down to fill in the table. Okay, good. Now, the next step would be to sum up all of these values. So we would say sum of these values right here. Okay, so we get negative 225. So to compute the sample covariance by using the formula, it's the sum of these products divided by n minus 1, right? So in our case, n is equal to what? 1, 2, 3, 4, 5, 6, 7, right? So the long way to do this would have been equal this summation right here divide by, well, let me do it so you guys can see it's 7 minus 1, which is 6, right? Okay, so we get negative 37.5. So sample covariance gives us what? It tells us the direction of the relationship. It doesn't tell us the strength, but the direction means what? The negative represents that as X goes up, Y goes down. And that makes sense because as the price of a product, in this case it's a printer, as the price goes up, the demand goes down. Okay, now how would I do it the short way? To do the short way, we would do what? Equals, and then this is covariance, right? So we're gonna do covariance, and we just type it in, covariance dot S, because we're dealing with a sample. Array 1 is your independent variable. Array 2 is your dependent variable. And we get exactly the same thing. Okay? So on your homework, you will be prompted to fill in a table like this. But once you just need to compute covariance, this is your shortcut. Okay? Covariance dot S, that stands for sample. Highlight the independent variable first, and the dependent, and then you get your answer. Okay, so this is how we compute covariance of a data set that tells us the direction of the linear relationship. Okay, what this number doesn't tell us, it doesn't tell us the strength, and that's what we do that's what we need to do now to compute sample correlation coefficient that which will give us not only the direction but also the strength of this linear relationship. Okay, so let's see how we do this the long way, and then we'll do it the short way. We need to compute the sample standard deviation for the x, and you would just do it by doing STDEV, that stands for sample standard deviation of a sample, right? Okay, highlight our cells. Then sample standard deviation for the y variable. We get these numbers, okay? And then the sample correlation coefficient is computed by taking the sample covariance and dividing it by the product of these two. Okay, so we get negative 0.6269. Okay, let's check this with a shortcut. Okay, you would say equal correl, and look, the description says returns the correlation coefficient between two data sets. Okay, we open the parentheses, highlight the first one, highlight the second, close the parentheses, enter. Okay, and look, we get exactly the same thing. So what does this tell us? That the relationship is moderately strong. The closer it is to -1, the stronger it is as far as the linear relationship goes, right? So you would say here, what is your relationship between x and y? As the price of this printer goes up, the demand goes down, right? And that makes sense. Let me make it like this, okay? Because as the price goes up, people will not want to buy this anymore, right? So the demand will go down, okay? So again, what does sample covariance measure? It measures the direction, negative, okay? The sample correlation coefficient measures direction and the strength. This number right here should be between -1 and 1. Okay, the closer it is to +1, the stronger positive linear relationship is, and the closer it is to -1, then the closer the negative linear relationship is. And if it's close to 0, then we say it's either a weak or there's no really linear relationship, and we're going to talk more about it in the next chapter. Okay, all right, this is how you guys would compute your covariance and correlation coefficient for bivariate set of data. Thank you for watching.